Well, I hope you noticed that there was an authorization theme of this track so far. So I figured we should start there with our roundtable discussion. And I'm looking at the new updated OWASP top 10 API risks. I mean, it's like broken object level authorization, broken authentication, broken object property level authorization, broken function level authorization. There's so much that can go wrong with authorization with APIs. So my first question is, why is this the case? Why is authorization such a prevalent risk associated with APIs? And what sort of damage could these sort of authorization gaps cause? Judith, maybe you want to take this one since you're new to the stage?
Yeah, I can take this one. But I'm also going to talk about this in my
yes,
talk. So
that's true. That's true.
So
it should be easy.
Too much. No, but it's hard. It's simply as that. It's hard because it's business logic. It's not the same for everybody. So it's not like just copy and paste. And it requires you to think and plan and identify all the paths in the tree. I think that's simply the answer. It's hard, and we can see that in the OWASP list, since you have all those different authorization problems as identified as a high risk.
And then when you scale it with all the different applications and all the different programming languages, like what you showed us, Anders, it seems like all that could just escalate exponentially.
Yeah, yeah. I used to work in identity, as you're aware, where there basically is. There's one place you go for authentication. There's once the token is issued, it's valid for an hour or maybe a whole day, while authorization is just per one issued token. There's probably 1,000 authorization decisions. So just the kind of sheer scale of it makes it so much more complex, but it also makes it so much more interesting.
Yeah. Erik, anything to add there?
Yeah, I would say that privacy by default perspective, security by default is kind of, I mean, everybody knows that there's a way to go, but what's actually happening is typically convenience by default, that engineers rather pick the convenient path first, and then they do the complexity, the security part later, and that's where I think you have most of these problems.
What does that look like in practice, like the convenient way?
I mean, I think it also comes to like a lot of managed services, that every time you subscribe to something, you get it full open by default. I think it's kind of, you make no decision, that basically means unsecure, and you need to make decisions to get it secure. I think that's the way.
That's a good point. A lot of these managed services can just come with like a lot of open security defaults that can be misconfigured. Malcolm, anything to add on why authorization is so prevalent?
Yeah, I think the reason is because unlike authentication, which is dealing with identity, which is almost a solved problem in that a lot of people have identities, if not online, they have Facebook logins, and people's identity is already established online. It's certainly established inside a big organization. You'll have a group directory, you'll know the staff. So unfortunately, authorization actually involves a connection to the domain. And so, for example, if you wanted to make an authorization decision based on a patient, does the patient allow other doctors in the same doctor's department access to their sexual history, right? That might be consent-based. Now, all of those things are to do with the domain. And unfortunately, because you can't solve that generically on the edge of the network, you have to rely on people programming. And anything that relies on people programming in a multitude of other languages, as you said, Anders, is fraught with problems and debugging. And it's very hard for code to be kind of read by a scanner. It's very hard for it to be interpreted. And I think that's really cuts to why it's such a difficult problem to solve.
Yeah, I mean, you're going to be working with a lot of these people, creating these roles and permissions. I mean, how do we scale something like that and manage it? Anders, maybe you want to start with this one, since you're
I guess that was basically the topic on my talk.
Yeah.
So I think essentially like the number one problem is like having to do lookups at the time of a policy decision. So whatever you can cut off, like at least a few of these lines pointing to your database, that's a big win. So yeah, if there's just one thing that you should consider, but of course, you still need to authorize, and you still need to do that securely. So it's not just a matter of removing those calls, but how do we replace them with something that's more scalable?
Right. I'd also like to set the scene on like the potential repercussions of not addressing some of this. Like, what do you see are the damaging like business repercussions of not addressing API authorization correctly? Because it seems like you could expose a lot of unintended consequences. Anyone could take this. Sorry, maybe Erik.
I guess it's a hard question to answer because it all depends on what capabilities of the APIs it protects, right? But it could be kind of devastating, obviously. Then I guess that some types of businesses have even the kind of compliance requirements and stuff to deal with it, that are there to cater for these kind of things, that you can't dodge all of these kind of things. But I think it's it could be all the way to kind of totally devastating and for people or businesses. Yeah.
So I think like a common thing I'm seeing in a lot of companies or organizations is basically that since doing fine-grained authorization is so hard,
right,
you basically have two roles. It's you're either a user or you're an admin. And once you want to do something more fine-grained, it means even more so if you hard code authorization, you need to go out to all these repositories of code, and you basically need to make each endpoint aware. What does this role mean for my endpoint? So that's a lot of work to do, leading to basically everybody in an organization being handed the admin role. Mm. And of course, most often they'll still have that admin role 2 years after they left as well. So, yeah, it's
or even the situation where you have an admin that unlocks certain privileges for people, but there is no process for unlocking those later, right? So I think it's also that kind of thing. Yeah.
Yeah. So it sounds like you could be running into like shadow permissions and permission sprawl if all of this isn't governed correctly, which is a whole nother risk factor I didn't really consider.
Another issue is authorization of endpoints is fine until somebody puts a /GraphQL, and then anybody can, with access to that, it's like your kind of admin role has access to the all the data assets in the organization. So really, it's about putting controls on the resources themselves, the data themselves, the data assets, rather than trying to rely on endpoint security or anything else. And role-based security is actually just, it gets you so far, but many people just rely on role-based security. But of course, most of the broken access control problems are when somebody has access to their bank account or their Peloton records, and that actually confers access to everybody's Peloton records by changing the URL. And there are countless examples like that.
It's amazing how many APIs are accessible like that. You can just change one little call in the URL and broken access control is very prevalent. And you kind of stole my next question in a way. I was curious, like, how do we address API authorization for different emerging API styles like GraphQL? There doesn't seem like to be one way to do it correctly, especially if like one endpoint is unifying a lot of backend APIs. Like, how do you trace authorization to all those backend endpoints? Anyone? Anders? Maybe we'll just go down the line on this one.
Yeah, I suppose there's two models. One where you try and do authorization before you go out to these like APIs, and one where authorization is done in each API, and then you kind of, even if one would be unauthorized, you can still try and compose a response of what you got back.
Yeah, and you touched upon something on your last kind of slides where you can have like policies on data level, not on service level, so to say. Right. Not on what you're actually about to do, but to basically have a data filter driven policies and those kind of things when you get those kind of,
Yeah, and I think like another like big issue in authorization systems, and even those using OPA, And I think that's one problem that Malcolm has helped solve or try and solve is of course, like most authorization decisions, they're based on a policy, but they're also based on data. Who is this user? And that data is commonly from a database. And when another thing we're trying to solve with a system like OPA is this problem of auditability, where somebody might say, 3 months ago, we had a user who were granted access to this, I don't know, somebody should not have read this medical record. So what we need to do then, we basically need to rewind time, 3 months in time, so we can replay that decision and say, why was this decision made? And of course, if you have a database where you basically have that database has changed with a high frequency in 3 months, so there's basically no way to replay that decision, because even if our policies are in Git, we can go back and check out the commits at that time, and we have all that in OPA. We know exactly which revision of a policy, but if you have external data, normally we have no means of rewinding a database 3 months in time. I'm sure you have.
I have quite an extreme perspective on this, actually.
It's extreme.
I think the only solution that's really available to us is one where every asset, rules, data, everything is in one consistent set of databases, and that set of databases has a quality of temporality, at least temporality, such that you can rewind and see exactly everything in a consistent record. So, for example, if a hacker tries to access the system, and then we notice, and then we revoke their access, but then a minute later they access the record. Why was that possible? Well, it was possible because the rule sets that were pushed down were subject to some delay, and you can't. So there are sort of timing and race conditions in our infrastructures. So the only sort of what I sort of talk about is this sort of thing called atomic architecture, where we try to move. We still have microservices, but we sort of make them stateless. And for important records like authorization records and things that we do need to protect, we do want to put those in a kind of a central atom.
Interesting. I'll have to wait for your blog post on that.
The blog post is out.
Okay. Perfect. So we're talking about the business logic that could be corrupted and abused. And this is not even a technical security issue per se, but it's more of a design, architecture, and an edge case kind of thing. I think this is sort of a fascinating realm of API security that hasn't really been touched on much. So yeah, I'm curious to get your thoughts on that and mitigations. We start on the other side of the line this time to switch things up. Malcolm?
Yeah, I don't want to sound like a broken record, but too many systems passing too many sensitive information between each other, and so when you have that at the level of kind of a large organization, very ad hoc in services that talk to each other, you get this problem where the state of the system is actually unknown. Nobody knows what the state of the system is. It's in the queues, it's in the messages, it's in various databases, and so it's very open for attack, and very, very difficult to secure. So I think that's just a part of it. What business processes are kind of encoded into pipes, and that really ought to be reconsidered.
Yeah, I think keeping things simple
Okay.
is a good approach. It's don't have too much data circling around. Don't have too complicated rules. Keep it simple. That may help.
Yeah, I don't know what to add, but a lot of business systems is not integrated and maintained by engineers. People just want stuff to work and they just get it together. So I think that could be one part of it.
Yeah. It's the thinking about just the functionality of the piece, not how it could be abused.
Yeah, something like that.
Yeah, they're not thinking from a hacker's perspective.
Yeah, yeah. It should be easy to buy and launch a new little tool, right? And no one else needs to know that you do it and those kind of things, right? Or no one else, but maybe not the entire organization or whatever.
Yeah, it's a tough question. I think like there's an opposing, there's a problem on the other side of that, which is of course like when you're too restrictive on things. And I think like I've been to many organizations where I need access to some system, and I'll need to either send somebody an email, or I need to call someone or walk over to somebody's desk to have that. And sometimes a process that will take weeks. And like as a developer, what I would want to do is just submit a pull request, have that reviewed. Like, and then of course that act is also recorded in code, and whoever reviewed it can be found later. So I think like one problem that we're trying to solve by codifying policy is also to try and make that whole experience nicer for developers primarily, or anyone in tech, of course.
Yeah. So. Interesting. Yeah, good approaches.
Yeah, I think we should be searching for. I do understand what that we do need some better culture, and having security engineers embedded with the development teams, and to get a kind of better sense of what we should be doing. But there are some times where technologists hit home runs and they solve a problem so absolutely that a problem disappears. And I'd give some examples. The use of garbage collection in Java and C# was just a huge improvement. The discovery of Git for used to have to stop working for a month, at the end of every release to do mergers and things, and so that solved that problem. I think in Google they have a very good authorization system called Zanzibar, which kind of solves the problem for at Google scale. It's a little bit like Open Policy Agent, but they have their own format. So there are certain. I mean, that thing requires kind of spanner database and atomic clocks and things. But there are some times where a technology solution really does solve an issue, and we should be searching and looking for those. They're hard to find, but they are out there, and we shouldn't give up and try and just resort to just trying to train everybody, because it's never going to be a complete solution.
I see. So you're kind of saying like there are tools and processes out there to help shift left API security testing, essentially.
When I say out there, I mean out there in the solution space that humans haven't discovered yet, as well as out there on that may be things that none of us have heard of.
Yeah. Interesting. Great. All right. We do have to cut it there. Another round of applause for our panel. Really appreciate this.